Hi everyone, this is another example of chapter 1. It is question 5 on page 27. Let's read the question first. Question 5. 2-point charge are brought closer together, increasing the force between them by a factor of 25. By what factor was their separation decreased? So let's examine the situation here. We have two charge, and by the way, in this problem, we're looking for the magnitude. We are talking about the magnitude actually, and it does not matter if the charge are the same, different, positive, negative, it does not change the answer at all. But in order to simplify or make it easier to visualize the problem, I'm gonna choose two positive charge. So the two charge are positive. What we are told is, initially the two charge are at a certain distance, and there's a force acting on these two charge. I'm gonna call that force F1, and as per Newton's third law, the force on both charge is the same, but in opposite direction. Then we take these two charge and bring them closer together, like in the diagram over here. I'm gonna denote that force F2. Now we are asked, what is the difference in the separation? So we need to consider the distance before and after we bring the charge closer together. So before, I'm gonna denote the distance as R1. To be consistent with F1 in this case, and the separation after we bring the charge closer together as R2. All right. Now we are also told in the problem that once we bring the charge closer together, the force is stronger. Makes sense. So it's stronger by a factor of 25. So F2 is equal to 25 times F1. Now we replace F2 and F1 by the Coulomb force formula. So we got Coulomb constant multiplied by the charge in absolute value again. We are only interested in magnitude here. Divided by R2 square, so this distance square, is equal to 25 multiplied by the Coulomb constant, again multiplied by the absolute value of the multiplication of their charge, divided by R1 square. Now note, the Coulomb constant did not change, the charge themselves did not change, so these two are equal over here, so we can cancel them out. So we're left with 1 divided by R2 square is equal to 25 multiplied by 1 divided by R1 square. If we isolate, we flip the R2 square on that side, the 25 on that side, we got R2 square divided by R1 square is equal to 1 divided by 25. We want the ratio between them, not the ratio between their square, so we square root both sides, and we get R2 divided by R1 is equal to 1/5. So the distance is now 1/5 the original separation, all right? So, or the radius initially, R1, is 5 times that of R2, all right? So the force decrease as you increase the distance to the square, all right? So if you double the distance, it is 4 times, the force is 4 times less strong. If you increase the distance by a factor of 5, the force is 25 times less strong, as is this case over here. All right, so we are done with this question. Let's move on to the next example.